digging Alex's shirt. Alex's shirt looks so good.
Ridiculous.
I want one.
Okay, number 1. Are we ready to focus? Learn some things?
You can come with us.
You can help us.
Not Alex. I was talking about Mr. Dribble, but Alex can come.
No. I clearly don't need any improvement in my wardrobe.
Kelly texted me. Well, no. Okay, I'll tell her after the recording's done.
Okay. So angle A is 35 degrees, angle B is 67 degrees, and side A has a length of 13. That is a classic angle side. So using our angle sum,
That's awkward.
we can say 180 minus 35 minus 67, and we would get that the angle C has to be 78 degrees. Awesome. Now we can start using law of sines, and we can say something like lowercase side b divided by the sine of 67 degrees will be equal to side A, which is 13, divided by the sine of 35 degrees. So in our calculator, we can say 13 times the sine of 67 divided by the sine of 35, and we get 20.86. Yes?
If I get the sine over the sideline,
That can still work.
fine.
Yeah.
It works.
Yeah, I always choose to make my unknown in a numerator because algebra is easier than.
Oh, you can switch them. So they.
Yeah. In general, even it's not a rule, but typically, if you take an equation, you can take the reciprocal of both sides, and the equation should still be true. The only time that gets messed up is whenever you take the reciprocal of something that could be 0.
Yes.
Right? Which can the lengths of sides on a triangle be 0? No. Can the angles in a triangle be 0? No. Or 180? No. Yeah. So then we can also say C over the sine of 78 degrees equals 13 over the sine of 35.
I know. What were we doing? I was playing Roblox. I think I was probably yelling at Switch.
Hey, I could have made you pay attention by yelling at you, but I think you'll learn the hard way. It's my philosophy in life. So you end up with side C equals 22.17.
You need a. Now, and I got it.
Okay, because that really helps you learn how to be a good student.
I actually
Student travel in high school.
I'm teaching you more than math here, dude.
I'm trying to get into college. I really don't care how I get the A. I just want the A.
Okay. Then expect another semester of pain.
My brother had a college professor that never gave B's. It was his policy. He only gave B+ assessments.
I would cry.
Nice. I like it. I might start doing that.
Stop!
Number 2. What we have here is a classic side-side angle. And because the angle given is obtuse, and the opposite side is smaller than the adjacent side, no solution.
I totally forgot that one. I'm stupid.
Okay? So that one was side-side angle, obtuse. Very easy check. The opposite side has to be larger. Okay, now here's how I graded it. I made problem 1 4 points. I made problem 2 only 2 points because I feel like it's very, very harsh to take a problem that has such a simple answer and has no solution, and then if people do all of this work and
I did
find
all
all
that
these
work.
solutions to take 4 points off, that just doesn't seem fair. So number 1 was worth 4 points, number 2 was worth 2 points, and then number 3 was worth 8 points, because essentially, because it's 2 triangles, it was like 2 problems in one. See, it's this is the type of time that you want to continue paying attention, so if you did bad on this quiz because you didn't pay attention, maybe learn from that.
That's because I pay attention.
That was pretty much exactly the words you used.
That was right before the quiz.
Okay, so number 3. This is another side-side angle where the opposite side is shorter than the adjacent side, but this is an acute angle, so that can still have solutions. First thing I'm going to do is check how that length compares to the perfect length. So my calculator, I say 7 sine of 34. Because 6 is longer than 3.9 but shorter than 7, this will have 2 solutions. So I'm going to do in blue one of the solutions. So we'll say a triangle that looks like that. We'll call this A, this C, this B. So 34 degrees, 6, and 7. Then our second solution will look like 34 degrees, 7, 6, like that.
But would it be the same?
Just imagine taking this side here, right, and swinging it until it hits the triangle again. So you're going to get this triangle right here, right?
Wouldn't they be like the same thing as the angles and sides?
No, look, I mean, guaranteed, if this angle is acute, it's going to be obtuse over here. Look at the size difference in these triangles. This blue triangle is way bigger than the red one. Could they be similar? Maybe. I don't know if there's a rule against it. Usually they're not, but that doesn't mean they're different. They're the same. You know, they're still different. Okay, so we start with law of sines to find angle C. So we have sine of 34 degrees over 6 equals the sine of angle C over 7. So in my calculator, I'm going to say the inverse sine of 7 sine 34 divided by 6. And so I get 40.72 degrees for angle C. I immediately, I'm going to actually store that for C in my calculator. I immediately subtract that from 180 to get the other angle C in the red triangle. Guys, please stop talking. So the red angle C is going to be 180 minus 40.72. So I get 139.28. And that is the obtuse angle C right here. Okay? So then we can use angle sum to find all of these other angles. So I can say, what's 180 minus 34 minus this 139.27 number? So that's 6.72. So B, whoops, it should be red. So you get 6.72 right here. Okay, and then I can also use that to find side B, because B over the sine of 6.72 is going to equal 6 over the sine of 34. So in my calculator, I would say 6 sine of this divided by the sine of 34, and I get 1.26.
So you're fine with us just rounding it to 2 decimals?
Yeah, that'd been good enough. Yes, sir.
When I started this, I thought I was solving the little triangle, and then realized my answers wasn't right. Why is that?
Wait, say that again.
So like I started with solving the little triangle, the red one, and I had like C was equal to 40 and D was equal to 139.
Okay.
And that was obviously not correct.
Why not?
Well, for that.
That is correct.
For the blue one, but I thought I was solving.
Well, just because you drew the triangle small doesn't mean you can't label it that way. Yeah, it looks silly, but you trust the way a triangle is labeled, not the way it looks, right? Just because this looks like a tiny acute angle, like really, this came out to 6 degrees. I look at this and say, "Wow, I did not do a good job drawing this," because that angle right there is way bigger than 6.7 degrees. So if you really want to make your pictures accurate, there's a whole range of what's acceptable, and I say, who cares how they look? Don't make them accurate at all. Yeah, So what? You started solving the smaller one first and you got these numbers. They're still correct. You're not going to miss points just because, oh, you labeled this one with the 40 degrees and this one with the 139. That's crazy talk. No, I don't care.
Why does it work to subtract the angle you know from the reading?
Because, so here's your solution, and then that side can rotate and also find a solution here, right? There's your two solutions drawn in one big triangle. This side here is the same as this side here. It makes an isosceles triangle, right? So one of the big things I focused on in those couple minutes before we took the quiz was drawing the triangles.
How do you, which side does, how does this one work? Like to fit together?
Huh? I think one of the big things is we're not really truly understanding how given this information creates a unique triangle, right? You have to create a triangle that has angle A 34 degrees, side C7, and side A 6. So the only way, so this has to be fixed, this has to be fixed, and this has to be fixed, right?
Yeah.
So this side here can rotate around that point. Right? Because this length is not fixed, this angle is not fixed, and this angle is not fixed. So if I take this side and rotate it around this point, that's not good because that changes the length of this side. So it's this point, the point where the two sides meet, that is your rotating side. You get a triangle here, you get another one right here. Right? Alright, let's continue solving this so we get a complete answer key. Angle B, nope, it's got to be blue, Angle B is going to be 180 minus 34 minus angle C. So that's 105.28. And then we go for side B. So 6 times the sine of 105.28 divided by the sine of 34, and we get 10.35. Nah, don't even worry about paying attention. I give up. No, that's fine. You want...